The last objective, number 5 for section 2.2, is explain the properties of water that make it important for living organisms. Include definitions of solute, solvent, hydrophilic, hydrophobic, reactants, and products. So when we look here, water's chemical structure enables it to perform 4 special functions. It is a good solvent. It facilitates a lot of chemical reactions. It's cohesive, and it moderates temperature. Let's look at each of these individually. Let's start out with definitions of some of those words. A solution is a mixture, a chemical mixture. In the graphic there, we've got salt being mixed with water, and we mix them up together and we make a salt water solution. The solute is the substance that dissolves in the solvent. So the solvent dissolves the solute, okay? Water is the solvent that dissolves the salt, which is the solute. You're going to have more of the solvent than the solute, okay? And because water is polar, a lot of different solutes will dissolve in it. So we refer to water as a universal solvent. Water has a polar structure. It dissolves salts and other polar molecules. Polar meaning it has a charge. This brings us to 2 other vocab terms in our objective: hydrophilic and hydrophobic. If the solution is hydrophilic, it likes water. It dissolves salts. It's hydrophilic. Alcohol is an example. It mixes well with water. But if it is hydrophobic, it doesn't like water. Hydro means water. Phobic means to fear. So it will not dissolve nonpolar substances, like cooking oil. Water and cooking oil do not mix. You can shake them, you can use a mixer, you can put them in a food processor, a blender together, and when you sit it out to the side and wait, it's going to separate. The water's going to be on the bottom and the cooking oil's going to be on the top. It's hydrophobic. But if it's polar, like salt is, water, hydrophilic to love. It mixes well. You can take salt and put it in water and stir it and agitate it and mix it and blend it, and you end up with salt water. It mixes together because it's a good solvent. It facilitates a lot of chemical reactions because it is such a good solvent. The second property, facilitating chemical reactions. Now, here again, we've got some of those vocab words. A chemical reaction is where you change the chemical composition of substances. And water helps this because it allows the solutes to have contact with the solvent for the chemical reaction. Here we have reactants and products. If you look at that chemical formula there, that arrow means to yield or produce. So our reactants, A plus X, we're going to have a chemical reaction happen, and they will produce our products, C plus Q plus R. The reactants are always going to be on the left side of the arrow, and the products are always going to be on the right side of the arrow. Reactants react and change to make products. Okay? A plus X, when they react together in a chemical reaction, are going to produce C, Q, and R. C, Q, and R are not at all like A and X. Look at them. You know that C, Q, and R are very different from A and X. But if we let A and X react together, we're going to produce C, Q, and R. The third property is cohesion. That means the molecules stick together. That's because of those hydrogen bonds. And there's many hydrogen bonds between the water molecules. We saw that previously. This is why you can water a pot that has a plant in it, and you water the soil and the roots, and that water is transported up the roots into the stem to the leaves, because the water molecules will stick together in a continuous column. The last property of water is it moderates temperature. Water has to absorb the heat energy, and all of the hydrogen bonds that are connecting the different water molecules to each other have to disrupt and absorb that heat energy. And once those hydrogen bonds are disrupted, that's when the water temperature will start to rise. Even though those hydrogen bonds break, the water stays liquid, but the temperature goes up as more heat is absorbed. So when you're standing there watching that boiler of water and you're waiting on it to boil and it seems like it takes forever, the reason it takes so long to get to boiling is those hydrogen bonds between the water molecules have to break, and then the water temperature will climb up to 212 degrees Fahrenheit.